We are now at question 4A, CSEC Math Exam, January 2013. And question 4A is asking us to make R the subject of this equation and also of this equation. So let's focus on this one first. We want to make R the subject. So we see a term in R here and a term in R here. So what we want to do is group the terms in R on one side of the equation so we can factorize the R and then divide so we can make R the subject. So what we're going to do is rearrange this equation such that the terms in R will be on the left hand side and the other terms will be on the right hand side. So the terms in R are this term here and this term here. So to get rid of the RH from this side, we're going to subtract RH from both sides, and to get rid of this H from this side, we're going to add H to both sides. So we're adding H to both sides and subtracting RH from both sides. So it's adding H and subtracting RH, and so this is what we are doing. We're adding H and subtracting RH on this side, and we're adding H and subtracting RH on this side, and so the equation remains balanced. Now this plus H will eliminate this minus H on this side, and on the right hand side RH here will eliminate minus RH here, and so on the left hand side we will have R minus RH, and on the right hand side we will have only H, and so it reduces to this: R minus RH on the left hand side equals H on the right hand side. The simple way to do this transposition really is to say we take this negative H over onto the right hand side and it becomes this H, and we take this RH over onto the left hand side and it becomes negative RH. So that's a quick way of doing this transposition. And now we want to make R the subject, so we need to factorize R out of these two expressions, and when we do that we end up with this 1 minus H multiplied by R. That's when we factorize R out of these two expressions. This is result, and we have H on the right hand side. And now to leave R as a subject of the equation, we need to divide both sides by a 1 minus H to get rid of the H from this side. And we can show that we are dividing now both sides by 1 minus H, and the 1 minus H here will cancel the 1 minus H here, and we'll be left with R divided by 1 on this side, which is R. And so that reduces to R equals H divided by 1 minus H, and that is the result. R is the subject. And again, the shortcut way of doing this transposition is to say we divide this 1 minus H under the H here, right? And so R equals H divided by 1 minus H. In any case, this is result. R is equal to H divided by 1 minus H. In this case, we have V equals pi R squared H. This is a formula for the volume of a cylinder. We are not told that, and so we have to make R the subject without giving consideration to this being the formula for the volume of a cylinder. And so to make R the subject, firstly we're going to divide both sides by pi H, because we want to get rid of the H and the pi from this side, so we can leave the R squared term by itself on this side. And so this is what would happen. We would divide both sides by pi H to get rid of this pi and this H, and the pi here and the H here will be cancelled by this pi H, and we'll be left with R squared divided by 1 on this side and V divided by pi H on the left hand side. And so that reduces to R squared equals V divided by pi H. And now to make R the subject, we need to square root both sides. Square root both sides to get rid of this square. And this is the result. But because we don't know whether R is positive or negative, when we calculate the square root of a number, we have to consider positive or negative. And therefore, this result would have a positive or negative square root of V divided by pi H. And then the square root of R squared is simply R. Square root of R squared is R, and we are left with R being equal to plus or minus the square root of V divided by pi H. And this is the result. R is plus or minus the square root of V divided by pi h. If we consider this original equation as the formula for the volume of a cylinder, then the R could not have a negative sign because radius cannot be negative, and so the negative would not be a value. But we were not told that for this question, and so we have to go through the normal way of considering both positive and negative when we calculate the square root of a number to reduce this side to just R. And so this is the result I would prefer to present. Alright, let's move down now to part B. In part B, we are given these two functions, f of x equals 2x plus 5 and g of x equals x minus 3 divided by 2. In part 1, we are asked to find f to the minus 1 of 19. And so to find f to the minus 1 of 19, I'm going to first find f to the minus 1 of x, which is the inverse of f of x, and then proceed to find f to the minus 1 of 19. Now the relationship between a function and its inverse is an interchange of the range and the domain. And in this function, f of x represents the range and x represents the domain. So when we take the inverse function, right, the range here will become the domain of the inverse function, and the x here, which is the domain in this function, will become the range of the inverse function. And so when we form the inverse function, this is what we'll get. This f of x, which is the range of this function here, becomes the domain of this inverse function, and this x, which is the domain in this function, becomes the range in the inverse function, and the range in the inverse function is represented by f to the minus 1. And so all we need to do is transpose this equation to make f to the minus 1 the subject. And what we can do therefore is take the 5 on this side and subtract it, and so we'll end up with 2f to the minus 1 equals x minus 5, and then we can divide by 2. So it's going to be x minus 5 and then divide by 2, and this is the result. F to the minus 1 will be equal to x minus 5 divided by 2. We take over the 5, make it negative, and then divide by 2, and this really is f to the minus 1 of x. So now we can show that. And therefore, if we want f to the minus 1 of 19, we simply substitute the 19 for the x here. And so f to the minus 1 of 19 would be 19 minus 5. That's 19 minus 5 divided by 2. And when we do this calculation, 19 minus 5 is 14. 14 divided by 2 is 7. And so f to the minus 1 of 19 is 7. Now in part 2, we're required to find g of f of 3. Now g of f of 3 is a composite function, g of f of 3, which can be written as g of f of 3. So it means we are calculating f of 3 first. It really means f of 3 followed by the function g. Now f of 3 is obtained simply by substituting 3 for x in this function here. And when we do that, we end up with g of 2 times 3, that's 2 times x, 2 times 3 plus 5. 2 times 3 plus 5 would be f of 3. And 2 times 3 is 6, plus 5 makes 11. So this becomes g of 11. And then g of 11, the value for g of 11 is obtained by substituting 11 for the x value here in the g of x function. And when we do that, this is the result. 11 minus 3. 11 minus 3 divided by 2. All we have done is replace the x here with 11. And 11 minus 3 is 8. And 8 divided by 2 is 4. And therefore, the result here, g of f of 3 is equal to 4. And that's the result for part B of question 4. Let's move down now to part C. In part C, we are given the equation of the line segment GH. That equation is 3x plus 2y equals 15. That's not in the standard form. And we're asked to find firstly the gradient of GH. Now to find the gradient of GH, we want to place this equation in the standard form. we have to place the equation of a line in the standard form so we can determine the equation of that line. And so for any line in the form y equals mx plus c, we know that m is a gradient and c is the y-axis intercept, and we must observe that we must have y alone, y by itself, as the subject of the equation of the line. And so we have to transpose this equation to make y the subject before we can determine the gradient. Coefficient of x will be the gradient and the constant term will be the y-axis intercept. And so for the line GH, we are transposing this equation into this form. So firstly, we'll take the 3x on this side and make it negative, or we say we subtract 3x from both sides, and this is the result. When we subtract 3x from both sides, we end up with 2y equals minus 3x plus 15. We're trying to write the equation of this line in this form. So what we need to do now is get rid of this 2. We must have y alone as the subject, and therefore we have to divide now this equation by 2 to leave y by itself as the subject. And when we divide through by 2, we divide each term by 2, and therefore 2y divided by 2 leaves us with y minus 3x divided by 2 is minus 3 over 2 times x, and the 15 divided by 2 is a 15 divided by 2 as shown here. And now this equation is in this form, and therefore our m, our gradient, is minus 3 over 2, and our y-axis intercept is 15 over 2. And therefore we can now determine that the gradient of GH is actually negative 3 divided by 2. This is a symbol for gradient. That's the gradient of GH is negative 3 divided by 2. Y equals mx plus c. That's standard form for the equation of a line, and that's the answer for part 1. The gradient of the line GH is negative 3 divided by 2. Let's move down to part 2. Now what we have so far is a line GH with the gradient of GH being negative 3 divided by 2. And now we are told of the line JK, which is perpendicular to GH and which passes through the point we have called it P41, right? And we want to find the equation of this line JK. So here we want the equation of a line JK which is perpendicular to GH and which also passes through the point which we have called P41. So since we have the point and we have the means to find the gradient, because we are told that it is perpendicular, we want to be using the point gradient form for the equation of the line. And this is the point gradient form for the equation of JK. Y minus YP. YP is the y coordinate of the point on the line that we know. MJK is the gradient of the line JK multiplied by x minus XP. XP is the x coordinate of the point P, the point on the line that we know. This is called the point gradient form for the equation of a line, and it is useful when you know the gradient of the line that you want and also a point on the line that you want. YP and XP, these are the coordinates of the known point on the line, and MJK would be the gradient of the line JK. P is the point and MJK is the gradient. So what we need to find now is the gradient, because we already have YP, we know that is 1, and XP, we know that is 4. So we need to find the gradient. But we're told that JK is perpendicular to GH, and we know the gradient of GH is negative 3 over 2. And so we can use the relationship between perpendicular lines where the gradient is concerned, and this is it. Perpendicular lines have negative reciprocal gradients. And what we mean by that is that since JK is perpendicular to JH, then the gradient of JK is a negative reciprocal of the gradient of GH. That is, the gradient of JK is equal to minus 1 divided by the gradient of GH, and this is the gradient of GH. So this calculation will give us the gradient of JK, but this calculation can be done quickly by simply flipping and changing the sign of the gradient. That's how this calculation is done. So since we have this as the gradient of GH and we want the gradient of the perpendicular line JK, that's what we want, the gradient of JK to place here, then we can flip this and change the sign, and that's how this calculation can be done quickly. And so minus 3 divided by 2, we can flip that, it becomes 2 divided by minus 3, and then change the sign from negative to positive, and the result therefore is 2 divided by 3. That's it. Flip this negative 3 over 2 and then change the sign from negative to positive. And therefore the gradient of JK is 2 divided by 3. And this 2 divided by 3 can now be placed right here for the gradient, along with YP, the Y value at the point, and XP, the X value at the point. And from that we will extract the equation of the line, and this is it. Y minus YP, which is 1, equals the gradient of JK, which is 2/3, which I have calculated from here, multiplied by X minus XP. XP we said is 4 because X coordinate of the point that we know is 4. And when we simplify this equation by multiplying this 3 across here and multiplying this 2 inside here, this reduces to 3y minus 3 equals 2x minus 8. This 3 we multiply it across here by the y and the minus 1 to get 3y minus 3, and this 2 we multiply inside here. And that's a quick and easy way of simplifying this equation. And so all we need to do now is take this minus 3 over onto this side and add it, or we can say we add 3 to both sides to get rid of this minus 3, and this is the result. 3y here is now equal to 2x minus 8 plus this 3, and minus 8 plus 3 gives us minus 5 on the right hand side. And so the equation of JK is the answer for this part of question 4C, and that's the end of question 4. And so we'll do question 5 in our next video. See you then.